You can start, Harsh. Okay.
Sure.
You can. There are students who want to. So if you see, right, there are requests coming in speak. So if they want, you can accordingly in the speak left side. There is a hand, right? Yeah. So if they want to say something, you can accept that and
Got it, sir.
okay.
Okay. Thank you, sir. Hello, class. Good morning. Good morning, guys. Good morning, Vishal. Good morning, Harni. Yes, Harni. You are on the mic. Yeah. Good morning, guys. Good morning, all of you. Okay, class. So, in this session, okay, class. Okay, good morning, all of you. Okay, good morning. Good morning, all of you. Please hold your keyboard. Please hold your keyboard, guys. So, there are a hell lot of strength. Guys, hold your keyboard. It's okay. We have done the good morning. Okay, class, all of you. Hold. So, class, this is your lecture on the tree. So, we are going to discuss about the tree. What are the trees? And you are learning data structures. So you have learned a couple of various data structures till now. So we are now going to discuss tree and what are its different types. How can we create tree and how can we iterate in a tree, or you can say traverse in a tree. There are various methods. So we are going to discuss all of them. Then there are a couple of questions. Couple of questions we are going to solve. Couple of questions we are going to solve. So class, yeah, good morning class, good morning all of you. I understand your concern, I understand your emotions. Please hold your keyboard. Now the session has been begun. So at least now listen me. As I know that you all of you are in the second SAM or maybe in the second year. I don't know which year students you are. It was told to me that you are a second SEM students. Yeah, good morning, guys. I understand your emotions. Please hold your pen. Please hold your keyboard. Now, at least listen me. Okay, class. So, what is tree? Anyone? What is tree? Now, the question is, what is tree? What is tree? Anyone? Sakti, good morning. Good morning, Jayant, all of you. But, class, the question is, yeah, good morning, Kokila. Good morning, Darshan. Guys, it's okay. Let's start the class. Let's start the class. So, okay, so someone is saying it is a non-linear data structure. Tree is also a non-linear stack. And Manoj, you have a very interesting answer. Tree is also a non-linear means stack, and REPDS means what do you mean by repetitive data structure? And Sarvana, you are saying a non-linear ADT. So I am writing a couple of answers. Someone is saying So we have first answer that it is a non-linear data structure. Okay. And what else we have? Someone is saying, guys, someone has opened their mic, please. And someone is saying it's a non-linear ADT. Non-linear ADT. Guys, anyone has opened their camera, please? It is a non-linear data structure which store data in a hierarchical order. Madhushri has also given a very interesting answer and very good answer. It is saying it is a non-linear data structure which stores data in hierarchical order. It is a non-linear data structure. Manoj, there is a tree is also non-linear stack and REPDS. Manoj, please unmute yourself. Non-linear data stack and REPDS. What do you mean by this REP? Does GS include for data structure? What do you mean by repetitive data structure, Manoj? A non-linear data structure organize elements in hierarchical or interconnected manner. Yeah, you are also correct. Yeah, good morning, class, all of you. A train is a non-linear hierarchical data structure. Yeah, all of you are correct. So, class, you as I understand that you all have knowledge of what a tree data structure is. So, if we understand it carefully, I would say that a tree is a data structure. A tree is also like just other data structure. Like we could say that tree, it is a data structure. What do you mean by data structure? Means it stores data. It stores data. And what else? It is non-linear. It is non-linear. Class, what do we mean by non-linear? Anyone with an example? What do we mean by it's a non-linear data structure? Guys, what do we mean by it is a non-linear data structure? A tree is a hierarchical data structure consisting of nodes where each node is a value and a reference to a child node with no one designated as the root. Achha, with one node designated as the root. Yaman Khan, I understand your concern, but we are moving a step by step. So there are non-sequential. Yeah, we have an answer from Lavanya. It's non-sequential and storing data in a random manner. Okay, so we, we can traverse it in more than one way, not as linear one. It is not a sequential order. Okay, class, I understand your concern. So what you want to think that class, unless like we have an array, so it's a not a matter of that we can not move in a sequential manner or we cannot go all that stuff. Unlikely, it can just go in one direction. Bharatram, Bharatram, let me correct you. If we have doubly linked list, we could move in any of the direction. If we have doubly linked list, we could move in any of the direction. Okay, class. So let me clear for you. It is non-linear data structure means like as you know that when we have array, so all the data is we could traverse the data in one by one fashion in a sequential manner. There are a couple of students who are saying that not in sequential, so which is a correct statement. So is we cannot traversal not in sequential manner. So I am writing the same thing. If we are not able to traverse in a sequential manner one by one. Okay, class. So that's why it is a non-linear data structure. But what are its uses? It stores this hierarchical data. Class, what do we mean by it stores hierarchical data? Data are not in continuous memory location. Shruti, you are correct. But when we store like in linked list, data is also not present in continuous memory location. Still, we call it linked list as a linear data structure. Shruti, is it clear? Shruti R. Is it clear? Shruti. Okay, guys. I guess it's clear. So, it stores hierarchical data. What do we mean by hierarchical data? So, as you know that even in your college, you have one dean. After dean, there are several HODs. For several HODs, there are certain professors. We have and certain professors, and they have assistant professors. Okay, let's say it is some type of hierarchical. First, on the top of the hierarchy, what we have dean. Then we have HODs. Then what we have professors. Then we have assistant professors. And you, then there are the students. Then there are the students. So we can say that it is some sort of hierarchical data. So at the top level, there is a dean. At the bottom level, there are students. So we can say that. So we can have more child Priyadarshini, but we are please understand that concern. We are going to clear all the topics. We are going to clear all your doubts. But first understand what history looks like. I know most of you have that knowledge, but I am considering it because there are more than 500 students. So I am assuming that half of you have the knowledge, but half of you doesn't have the knowledge. Okay. So I am assuming that there are around a century of students who don't have idea of tree. So I am targeting those also. Okay. So we could say that a tree is a data structure which is non-linear in fashion, and it stores hierarchical data. And why do we call tree? Why do we call tree it is? Because class, if we visualize it carefully, if we visualize it, so I could say that it is a root node. There are certain branches, and for certain branches there are multiple more branches. So in the normal life tree, there is a root and there is a stem. Then they have different branches, and from the different branches there are multiple more branches. So it resembles a tree-like data structure. It resembles a natural tree-like structure. It resembles a natural tree-like structure. Just like leaf. Leaf from the last nodes are called the leaf. In the normal tree, what are the leaves? The last nodes. You can see in this students are the leaf. Students, because it's the students, there are no further sub branches. Similarly, when you visualize the tree, the leaf do not have any further sub branches. So it resembles a natural tree like structure. Sorry, class. Huh. Yes, Lavanya, yes, Shakti, all of you are correct. So it resembles a natural tree-like structure. That's why we call it as a tree data structure. Class, now there are multiple type of trees. We are going to discuss all the trees one by one. But before discussing all the trees one by one, we are going to discuss them as we are moving ahead in this session. So we know now what is tree. Class, now how can we create a tree? How can we create a tree? How can tree has its branches same as child and parent tree and the leaf node? Guys, if I'm asking you a question, then please write something. Please do not flood the chat box. Okay, do not flood the chat box. Yeah, is it clear up to this point? Write all of you true in the chat box. If this is clear up to this point, write true. All of you guys, write true in the chat box. All of you. Class, am I audible? I'm sorry, there was some network glitch, so I was popped out of the class. Guys, am I audible, all of you? Class, am I audible? Class, am I audible? Okay, guys, so we are discussing about the tree data structure. So let's see that how the tree data structures look like. So class, generally a tree data structures look like we have a root node. In the root node, we have certain data like we have 100. Then it has different type. It could have multiple child, but we are assuming till now that it only have three childs. It only have three child. So I could say that this is a root, and there is a one more, and it has like 90, 80, 70. Then they could have multiple childs. They could have multiple childs like 10, 20, 30, 50. And they could have multiple childs also. Minus. So class, this is basically what I could say that this is my tree, in which this is what root. These are the different branches, and these are the last nodes. These are the last nodes. I could say that leaf nodes because they do not have any further branches. They do not have any further sub branches. Is it clear now? They do not have any further sub branches, so that's why I'm calling them. These are the leaf nodes. Or someone has mentioned that, or either terminal nodes. Terminal nodes. We could say them a leaf node, or we could also call them a leaf node. Is it clear? Write one, all of you in the chat box. Write one. Guys, write one, all of you. Okay, class. Now, generally, there are multiple type of trees. There are multiple type of binary tree. There are multiple type of trees. I'm writing here. There are different type of trees. Different type of trees, but we are going to learn them one by one. So class, now we are going to discuss about a binary tree. Now we are going to discuss about what a binary tree. Binary tree. Okay. I am just going to discuss the different type of trees. First, we are going to discuss about binary tree. So class, what is a binary tree? It is a tree. Class, in this tree, what is the how many child does this root node have? Class, how many child does my root node have? Class, how many child does my root node have? What do you mean by Darshan? Root node have three childs. Root node have three child. You can say one, two, three. So I am saying that in this tree, my root node has three child. This node has one child. This node has two child. This node has one child. This node has again one child. So I could say that it is some sort of like triad tree. In this, some sort of, I am not sure, but some sort of, in which that each node has at max three subchild. Each node has at max three subchild. So class, what is the binary tree? The binary tree is a tree. Binary tree is a tree in which each node can have at max two child. So guys, what does this line mean? Means in binary tree, each node can have at max two child. Either there would be no child, either there would be one child, or max to max two child. So if I draw certain trees like class, this is my binary tree or not? This is my binary tree or not? Class, is this is binary tree, this is binary tree, or this is binary tree? The answer is one yes, two yes, three yes, or just give the answer in the format yes, 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 or yes, no, yes, whatever you wanna give. Just give the answer. So class, this is my. And what are the binary tree? A tree in which each node can have at max two child. So class, what is your answer? Yes, yes, yes. Surya is saying yes, yes, yes. Okay, so we have yes, yes, yes. The meaning is these all are what? These all are the binary trees. What? In this each node has what? Zero child. In this each node have what? One child. In this node has two child. This node has zero child. This node has zero child. Again, this node has zero child. So what I am saying that all the three trees, each node has at max two child. Each at max it is less than two. So I could say that these all are what my binary trees. These all are what my binary trees. So this is the concept of tree and the binary tree. Because now we are going to discuss about how can we create this binary tree using C++ or any other programming language. So class, now I want to create this binary tree. I want to create this binary. I'm creating a tree which have at max two child. Okay, class. So we are creating a binary tree. Which is a binary tree. So class, we are creating a binary tree. So how can we create the binary tree? Anyone? Yes, Tarika Shri. Please let us know. Class, if you all agree, na, the user would give me some input like this: 1, 2, 3, 4, 5, 6. He just create a binary tree for me, and assuming that the tree should look like this. The tree should look like this. So how can we create this tree? So class, how can we create this tree? By recursion function, yeah, there are different type of approaches. But what I am saying you, please understand that this is very useful. So class, what I am going to do that, try to make a full binary tree. Class, we are going to discuss that what is a full binary tree, what is a binary tree. We are going to coming to these concepts one by one. So it would be very clear to you. So class, now we have discussed different types of trees. So we discussed binary tree. Now I am going to discuss about what is full full binary tree. Okay, it would be difficult for you. It would be class. We are going to discuss later these concepts. We are going to discuss later because they require certain different knowledge. So class, let's assume that if there is no node present in this, if this node is empty, so what I am assuming, if there is no node present, I would assume there is a -1, and these are the leaf nodes. For the leaf node, the left and the right sub nodes are again what? -1. Guys, again I am repeating. Right node. Sandhya, you are saying that you are talking about binary search tree, BST. You are discussing about BST, but we are not discussing BST here. Chandya, is it clear? So class, what we are going to do, we are going to create a binary tree. So suppose I want to create a such type of binary tree. Let me make it. 1, 2, 3, 4, 5, 6. And those values are empty. I am assuming that there is minus 1. If it doesn't have any child, because we are assuming it is a binary tree. So for those leaf nodes which do not, for the leaf node, I am assuming that for a leaf node, I am assuming that there are minus 1 as left and right subtree. Class, is it clear? Sandhya, okay. Class, is it clear, all of you? Write 8 in the chat box if this is clear. That how we are going to create this. I haven't write a single line of code till now, but we are going to discuss it theoretically. So now we are going to beginning with the code. So class, is it clear, all of you up to this point? Write 8, all of you. Write 8 in the chat box, all of you. What about others? Okay, class. So class, now we are going to discuss, we are going to make this. So class, if I want to take a user input for this type of binary tree, okay, let's make a smaller one. Class, if this is my binary tree, so I'm assuming that this is minus 1, here is also minus 1. For this, right is minus 1 because there is no right subtree. For this, left and right both are minus. So if I want to take input for this, so the input would look like that 1, now 2, then we have 3, then minus 1, then again minus 1, then we have taken the 2, now this is again minus 1, then we have 4, then minus 1, then minus 1. So class, how we are taking input? How we are taking input? Let me repeat it again. First, I have taken this 1 as an input. Then I don't know that how many left is there. So I am moving left of it. I insert, there is a 2. I make it as a left subtree. Then again, I move towards my left. Now there is a 3. I make it 3. Now I am moving again to my left. I encountered minus 1. Means there is no further left. I come back to 3. Now I would move to the right. Then again I encountered minus 1. What does it mean? There is no right. Okay. Then what I am going? I am going back. Class. Now left is covered. Yeah, who is there? Now left is covered. Now we are moving in the right side. Again, what we encountered? We encountered minus 1 means there is no right subtree for this 2. So now we are moving back. Now we are at 1 again. Now we are moving in the right direction. Now what we encountered now? We encountered 4. So we make 4 this as a right subtree. Now for the 4 we are moving in the left. What we encountered minus 1 means there is no node at the left. We go back. Now left is covered. Now we are at the root. Now we are moving towards the right. Again we encountered what? Minus 1. Again there is no right node for this 4. We move back and we come to move. So if this is the input, like 1, 2, 3, minus 1, minus 1, minus 1, 4, minus 1, minus 1, we are getting this as a tree. 1, 2, 3, and 4. So how does the pseudocode would look like? How does the code would look like? So class, I could say that before moving ahead, what I am assuming that in each node, this node is something like this. It has a pointer which is pointing to the left subtree. It has a pointer which is also pointing to the right subtree, and there is a one space in which we are storing the data. So I could say that my each node is something like this. There is a data, there is a left pointer, and there is a right pointer. Class, is it clear or not? My each node looks like this. As you can say that 1, it is also have the pointer to the left subtree, it is also the pointer to the right subtree. Again for this 2, it has pointer to the right subtree, it is also pointer to the right subtree. But the right subtree in that case is what? Null. So I could say that my each node looks like this. There is a left pointer, there is a right pointer. So if we create this type of structure for this, so how it would look like? We have one, now it is pointing to the left. So this data in this, there is a pointer which is referencing to this node, and there is a, I'm calling it P1 and calling it P2, and then in the P2 data is 2, and it is also pointing somewhere. This is not pointing. Again, there is a pointer, and this P1 of this is pointing to this node. In this, there is a 3, and this pointer is pointing to what? Null. Again, this pointer is pointing to what? Null. Again, this pointer is pointing to what? Null. So this, the node structures for this simple data structure look like in this fashion. Their pointer which are pointing one by one. So again, the right pointer is pointing to the node in which we have 4. There is again left P2 and P3, and again they are pointing to what? Null and null. So for this, for simple, first we are writing it. We are writing it in this fashion, so it looks easy to us. But in the end, actually, this is happening. There are 2 pointers left and right which are pointing like this. Is it clear? It how that all the things are working? Sir, can you please repeat? Okay. So I was saying 2, 4, eat double it. I was saying that if our tree is looking like this, so what I just said that our each node looks like this. There is a data, and there is a pointer which point to the left subtree or even the left child, or there is also a pointer which also points to the right subchild. If it is a binary tree, because it is pointing to the left and the right. If it is tritree, there would be one more extra space. Is it clear up to this point? 006. Is it clear up to this point? 006. 006. Is it clear? Double 006. Okay. So in this pointer P1, it is a left pointer na? It is pointing to this node which contains 2. And this P2 is pointing to the that node which contains what? 4. In class, there would be again 2 pointers P1, P2. There would be again 2 pointers P1, P2, where P1 is pointing to left and where P2 is pointing to where? Right. Again, this P1, the left of this node which contains 2, it is pointing to what? The node which contains 3. Again, this has P1 and P2. But here, the P1 is pointing to nothing. Because it is pointing to null. So there is nothing. Na? Again, similarly, this P2 is also pointing to null. Again, we don't have any right subtree for this true. So again, this is also pointing to what? Null. Again, in this 4, there is no left, there is no right. So I could say that this is also pointing to null. This is also pointing to the null. So if we are taking input, we cannot take null as an input. So I am assuming that null values are -1 values. You can say that, na? I am taking input as -1, -1. So with the help of keyboard, we cannot take null values. So I am mapping -1 as a null value. So if we are taking input, our machines understand if we are taking -1 means we are encountering the null value. So we should do not create node on the left of it. After 3, what I am giving -1 means -1 means it is a null value. So means there is no value. So we have to move back. Guys, is it clear enough to this point? Guys, write all of you. Write 7, all of you in the chat box if this is clear up to this point. Guys, write 7, all of you in the chat box. Okay, class. Now we are going to what? We are going to create tree. Now we are going to create tree. So class, before creating tree, you know that how we create the linked list? We create a class with the help of node. So there is all that fashion. Class, do you remember how we create the linked list? Class, do you remember how we create the linked list? Okay, yeah. So we are going to create that tree because you said this is also a node. In that in when you were creating linked list, there was data and a single node. But when it was a doubly linked list, there was forward node as well as the backward node. So we are going to clear in the same fashion. So we are creating a class, and I am giving this name as a tree node, and I am creating certain values. I am giving like int data and creating left and right, 2 pointers, tree node star left and tree node star right. And I'm creating what? One constructor. In this, we are getting certain data. And I could say that this dot data is equals to well, and where left is pointing to null. Because class, for each node, when there is nothing, it is pointing to the null, and right is pointing to the null. So this is the class. So why we are creating class, guys? Why we are creating class? Why we are not using any other data structure? Anyone can give me that satisfied answer? Why we are creating class? Yeah, Vidur, Viduran, why we are creating class? Why we are not using, sir? It's my choice. I could create map, or in this, the left map is moving this, right side, whatever. Why we are using class? Why we are not using any other data structure? And what is the class? Because this concept is very different data types. There is no root. Priyadarshini, different data types. I cannot do this like I can this na ki like if we are talking in C plus, if we are making a map, int is string, or in the string we could have one more another map like int comma string. We have another another map. We could do nesting of different type of data structures. A heterogeneous data type. This is also correct. Plus, this is one of the answer. This is one of the answer. But one of the major concern is that what I find very useful, because this concept is going to help us for solving around more than 15 to 20 questions in the nearby future. So class, we know that now what are the class? Classes are the user defined data structure. When we learn class, what are the classes? What definition of class? Class, what are the definition of class? A simple definition. A class are the user defined data structure. A user defined data structure. Yeah, you are correct, all of you. So I could say that you could use a struct also. Yeah. It is user defined data type. Yeah, user defined data type. So we are creating our own data type. In that data type or data structure, I am saying I am have such sort of feasibility that it has data, it has two pointers, it has int value and it has two pointer. If someone asks me create data type in which we have a string, we have an array, and we have a linked list. So I could also do that. I would create a string, I would create array, and I would create another linked list inside my class. So I could say that my data structure would have a string, would have array, and would also have linked list. This linked list could it could extend in any other direction. I have no idea. A collection of okay, we are not going in hooks, but it was general random thing. So please don't dive into. Let's remove this. Okay, class. So this is simple. What? This is simple class. Now, if user is giving such sort of input like 1, 2, 3, -1, -1, -1, then 4, -1, -1. Okay. So I want to create tree. I want to create tree. So class, I am writing a function create tree. I am writing a function which would do all the stuff. I am writing a function. The function name is create tree. Okay, and we are creating tree recursively. We are creating tree recursively. Okay, with the help of recursion, we are doing all that stuff. We are creating tree recursively. Yeah, we would put okay. It's a pseudocode. It's a pseudocode. Thank you for pointing out the silly mistakes. But if we are not writing the actual code, don't go for the coding mistakes. Go for the logic. Okay. But still, thank you. So we are writing a function like create tree, and let's make it because from this function we are returning the root. We are returning the root. We are returning the reference to the root. Reference to the root. So we are creating tree node star a pointer of this data type. Tree node is our data type, and we are creating pointer to that value. So that's why we are writing tree node star. Okay. So we are creating a create tree function. So let's what are the first step? First step, there is some data. User is giving me certain data. So let's write this. I could say that int data and C in data. We are taking data input. We are taking data input. And first, what is first? Let's check whether it is -1 or not. If it is -1 means there is no root, it is pointing to the null. There is no data, we are pointing towards the null. Yeah. Okay, so there is no, if it data is -1 means we are pointing to the null. So let's check that. Let's check that. Okay, so we are going to check if data is equals to -1. Let's highlight this. If data is equals to -1, do what? Do something because it is null. So simply say it is null. Clear class clear up to this point. As you know that na, this if this data in this left pointer we are moving towards the left and we are encountering -1 means it is null. There is no data, it is null. So return null. Guys, is it clear up to this point? All of you write 5 in the chat box. If this is clear up to this point, class write 5 in the chat box. Okay, guys. So Okay, now it is not. We are creating null. Okay, if it is data, so we have to create node for it. You can say if it is one in this case, so we have to create node for it. So we are creating node for it. Because now we are creating object of our class. We are creating object of our class. So how can we create tree node star? And I am just calling as what? It is a node, or I am just calling it as a root because root is a good word because this is root one tree node star root, and we know the drill new tree node and with the help of this data. So what we are doing, we have created a one node which one as a data, and this is null initially and this is null initially, because we can say that in our constructor it is null, it is null. Okay, class. Now we have to do it recursively. Means now we have to again take the input and we have to do all the stuff. So now I have to go in the left of this and do the same process recursively. Again, we have to go in the right of this and we have to do the same process recursively. So what can I do now? I could do that in this roots left. In the roots left, again run the same function, create tree. And again in the roots right, do the same thing, create tree. And in the end, you have created all the tree. Return root and end of the function. Return root, end of the function. So class, is it clear to this point? Class, there are only 1, 2, 3, 4, 5, 6, 7. Only 7 line of code. Class, is it clear up to this point? Class, is it clear up to this point? Guys, is it clear up to this point? Guys, write all of you. Write clear. Guys, write clear all of you in the chat box if this is clear. How we are creating a tree. Guys, write clear in the chat box. CLEAR, clear. Fourth line doubt, sir. What is Priyadarshini? What is the doubt in the fourth line? Please let me know. Priyadarshini, in this line, okay, let me write this line again for you. So you are saying there is a doubt in this line. Guys, when you create object, how you create object for any class? You can say for the tree node class, we are creating an object. We are creating an object. So how can we create a class? If there is a class car, if you want to create object for it, how you create the object? Like car star nano equals to new car, and it's whatever the parameters you want to pass. You do the same stuff, Priya Darshini. Priya, am I audible? So we are doing the same stuff. We are creating an object for our class. Tree node star root, and we are creating this root with this value data, which is user input, this data. And we are doing the same stuff in the left, we are doing the same stuff in the right, because initially the left is null, the right is null. So root left is null. Now we are creating a create tree function here and we are returning the root. So what I am assuming here that this is one root for this complete binary tree. For this binary tree, this 2 is node. For this tree, this 3 is node. For this tree, this 4 is node. So we are creating small trees. With the help of these small trees, we are connecting back them to get the bigger tree. We are connecting them back to get the bigger tree. So class, this is the way that we could create our tree. This is the way we could create our tree. So I could say that what we have done till now, we have declared a class tree node. In this, what we have data, we have left and right pointer, and what we declared a constructor. In this constructor, data is set to be value, and left and right are set to be null. Okay. And now we were creating a create tree function, and we have written this. There's 7 line of class. Now we have created a tree, and the tree is looking like this: 1, 2, 3, and 4. Now the thing is, now I want to print that tree. Now I want to print that tree. So there are different ways. What is the most common way? How we have taken the input? We have taken the input one by one. First we have taken 1, then we have taken 2, then we have taken 3, then we have taken 4. So class, how can we do this? So how can we print the tree in the same fashion in which we have taken the input? How can we traverse the tree? Or so the more specifically I want to say, how can we print the tree? Guys, we have created a tree. Now how can we print? How can we print the tree or traverse the tree? Print means class traverse. As you know that now when you create array, then you also know how can we traverse the array, means how can we iterate through the array. So now we have created the tree. Now the question is, how can we traverse our tree? How can we traverse our tree? Guys, anyone? How can we traverse our tree? In order pre-post. All know that. Okay. Okay, yeah. So we are going to do one by one. Firstly, let's code this, what we have done until now. Then we are going to do the next step. Okay. So firstly, let's code this. Guys, let me know. Does my VS code is visible to all of you? Guys, my VS code is visible to all of you? Okay. So we are going to create tree. Plus, this is a basic function. This is a, you all know that this is a basic piece of code. So there is no need to explain these basic lines of code. Okay, so class, what the first step we are doing? We are creating a class. We are creating a class of tree node type, and in this class, what we are doing? We are creating certain things. We are creating int data, and we are creating two pointers, left and right, and semicolon thing. Someone mentioned it. Why it's not working? Okay, let's write it in the separate line. Okay, class. Now we are going to create a constructor, and in this constructor we have what int value, and we are visiting this data to be very well, and left is pointing to null, and right is also pointing to null. Class, this is clear up to this point? Guys, is it clear up to this point? Sir, can you use C struct instead of CPP class? Yes, we could call it instead of class. If you want to do, we could use a struct. We could use a struct. There is no way, nothing. It's okay. NETHR in HR, is it clear? Is it clear? Okay, so it's okay, completely okay. They both have same functionality. Now what we are going to do, we are creating a function, and the function was we are we are returning the reference. We are returning the reference to the root node. So that's why I'm writing tree node star. Tree node is a class type, data type, and star means pointer. So we are pointer, we are path, we are returning the reference, we are returning the pointer. So that's why I'm writing tree node star. And the function name is create create tree, and it's expect nothing. Okay, now what next? We are assuming a data, and we are taking the data input, and if we see that data is -1, so do what? Simply return null, because it is a dead end. Class, is it clear up to this point, guys? Right? Okay, is it? Class, now, class, we are writing the exactly same thing that we have written. We are writing the exactly same thing. We are not writing anything extra. We are not writing anything less. Now, what next? Let's create a node, tree node star. I'm calling it as a node with the help of this data. Okay. Now we have created that. We have created that node. Now in this root left, do the same thing. And similarly in the root right, do the same thing. Yeah, create, call this function, and similarly call this function. In the end, return root. Okay, in the end, return root. Class, if we are returning something, we should catch it in the main function. If we are returning something, we should catch it in the main function. So, in class, we are returning what? Reference. We are returning what? Pointer. So, it should be like create tree. So, this root is a root node. This root is pointing, I could say that now. This tree star root is our reference to our root node. The reference to our root node. Class, this is clear up to this point. Guys, this is clear up to this point. We are writing all the things very clear. Yeah, we what you are writing, Harshita? Tree node star create node root left. Why you are writing your name? The attendance is taken care by your college and this algo tutor platform. There is no need to worry about. Okay, class. Now this is the point. Okay, we have done this. Now I want to print. Now I want to traverse. Now I want to traverse. Class. Now I want to traverse. So there are different ways I could traverse this tree. Now understand what are the different ways. Because there are different ways. How could I traverse this tree? So let's discuss those. So if tree is looking like this, one, two, three. So class, mark. This is my root. This is my completely left subpart, left subtree, and this is my completely right subtree. And again, if we observe carefully for this left, this is root of this is root subtree, and this is the left of this, and there is no right. Again, for this there is no left, there is no right. It is a root for this right subtree. Is it clear what I am saying? Okay, I think this is not visible to you. Guys, let me write it again for you. If this is tree, one, two, three, four, so I could say that this is my root and this is my left subtree and this is my right subtree. Guys, I can say that or not? Guys, write one, all of you in the chat box. One, all of you write. Guys, write one, all of you. Okay. So class, there are a couple of ways in which we can traverse it. So how we have taken the input? One, two, three, four. We have taken input in this session. So what are different ways? Firstly, I could print this root. I could print this root one. Then I could go into the left subpart. Class, now listen carefully. In this left subpart, I could say that if this is left subpart, the left subpart is looking like this 2 comma 3. So in this left subpart, this is what? This is again root and this is again left of the left. Class, do you agree with this part? Write true, all of you. Do you agree with this part? Guys, write true, all of you. Do you agree with this part? Guys, write true if you are agree with this, or otherwise write false. Okay, guys. So what can I do? What can I do? I could say that na, if first I am taking the root, I am playing only with the root. This is root for the main subtree, main tree. This is root for the left subtree. Again, this 3 is also root na. For this tree, this left subtree, this 3 is also tree where there is no left, there is no right. So I could say that each in my tree, either there is a left, either there is a right, or there is a root. Only there are 3 parts in which sometimes left doesn't exist, sometimes right doesn't exist, sometimes none of them exist. The left exists, otherwise right exists. There is only the root. just like here. We can say that. We can say that. So what can I say that if I am printing, if I am printing my root first, what is root in my this? 1, 2, 3, 4. So class, what is the root of main subtree? What is the root of main tree? The root of main tree is what? 1. Now we are moving towards the left. What is the root of this left subtree? True. Now again we would move left with left of the left. Now what I encountered? 3. Now what is the root of this tree? What I get? 3. Okay. Now is there any further left? No. We have reached the end. We have reached the end. We have reached the end. So class, what we are doing? We are printing the root and we are moving the left. We are printing the root, we are moving the left. We are printing the root and we are moving the left until we reach the bottom left corner. Until we reach the bottom left corner. So what we can see that, okay, we have printed the root, and we are moving toward the left. Now, with this session, what I am assuming is I've also printed the root and I've also printed the left. Now, if there is something, if trees was something like this, 5, there is nothing left. But class, now for this subtree, this 3 was a root and there was no left, there was no right. Now class, now we are moving towards the right. This 3 is already been printed. So all the game is on the behalf of this tree root, that if we are printing root first, then we are moving towards the left, then left is exhausted, then we are moving towards the right, and we are printing all the, it would be printing like this 5. Now it would move back, there is no right, it would move back, now it would goes to the right, and there is 4, there is no left. The 4 is printed, now there is no 5. So if it is printing in this fashion, if it is printing in this fashion, that first we are printing to the left root, then we are going to the left subtree, then we are printing the root of left, then root of left, root of left. Now when left is exhausted, we are moving toward the right, then we are printing the root of right, root of right, root of right, then all the root of right, then again left right combination. We are moving in same fashion. So if we are printing like root left right, this is one of the way. This is one of the way. What could be the way? I could print the left first, then I would print the right. What could be the other way? I would print the left first, then I would print the right first, then I would print the root later, then I would print the root later. So there are 3 different ways. There are 3 different ways, and 3 different ways have these 3 names. These names are based on the basis of location of root. If we are printing root first, we are calling it as pre. You can say na pre-order. Means the root is in the beginning, pre. If the root is in the middle, we are calling it in order. Means root is in the middle. If we are printing root later, it means post. Post means after, pre means before. So if root is before, we are calling it pre. If root is after, we are calling it post. Post order. If root is in the middle, we are calling it in order. So I am going to write a code for this pre-order, and the code would look like class. If I am writing this if pre-order, and in this we are passing to the reference to the root, this is taking, and for the first step we are checking class. Move pre-order means there is a root, to check whether root exists or not. Root exists or not. If root is equals to null, print nothing, return. If root is equals to null, do nothing, return. I am doing nothing, just return. There is nothing to worry. Then go what? Print the data. Print the root's data. And go towards the left. Call the same function pre-order and go towards the left. Then left is finished. Call the same function and go towards the right. And end. Go towards the right and end. So this is only the 4 line of code. This is only the 4 line of code. Guys, is it clear up to this point? Yeah, 3, 4, whatever you wanna say. Guys, is it clear up to this point? Okay, class. So let's try to code it. So class, now this is thing. So I want to create one function in order, and in this I am passing my root. So let's create this function here. It is void function because we are returning nothing in order, and tree node star root. So what is the first step? We are checking whether root is not null. Then if root is null, then return null. Otherwise print the data, roots data, and go in the left of it, and go in the right of it. This is basically pre-order, not in order. Let's try to test it. So if I'm writing giving as 1, 2, 3, -1, -1, -1, then 4, -1, minus. Because this was the input now 1, 2, 3, -1, -1, -1, -1, 4, -1, -1. It should be giving me the answer 1, 2, 3, 4. If we are getting a correct answer, so we should do something here like let's 1, 2, 3, -1, -1, -1, 4, -1, -1. So we are getting 1, 2, 3. Class, is it clear up to this point? Guys, is it clear up to this point? This is pre-order. Now class, now you have to create what? Create in order and create post order. Class, right? First of all, write one, all of you. Write one if it is clear to you. And now I have written what? Pre-order for you. Write the in order and write the post order by yourself. Write the in order and write the post order by yourself. Okay, class. So I am giving you a 10 minutes break. It is a 10-minute break. We are going to begin with at 10:30. We are going to begin with 10:30, and in this 10-minute break, what you have to do, you have to complete these two functions, in order and the post order function. Guys, am I clear? Guys, am I clear? So just complete these two functions, in order and post order, and we have a 10 minutes break. Okay, class. So complete this in order and the post order function. Like we have covered the pre order. Now we have to create in order and the post order function. Okay. Thank you, class. Let's see you at 10:30. This is a small break for 10 minutes. Okay. Hello, class. We are back. Guys, am I audible? Aman, Jahar, Ram, Karthik, Sajid, Shantini, Jiva, Sandhya. Guys, am I audible? Okay, class. So, have you done this? Void in order, pre order, post order? Guys, all of you, have you done this? Guys, write 10 in the chat box. All of you, 1 0. Write 1 0 in the chat box. All of you. Sir, can you teach us in C language? Actually, C. You are saying about the C. Actually, who is there? Shai Shakti. C and C++ both are the similar language. There are a couple of difference like taking the input and the output format. Otherwise, all the concepts are same. T Shakti, is it clear? 24CS 208. T Shai Shakti 208. Okay, class. So let's discuss something. So guys, let me complete these functions for you. Okay, this was the pre-order. In this pre-order, we are printing the root first. Then what we are doing, we are traversing the left. Then what we are doing, we are traversing the right. But what is the in order, class? What does the in order? The in order, there is the left, then we have root, then we have right. And in the post order, what we have? We have left, then we have right, then we have root. And in the pre-order, what we have? We have root first, then we have left, then we have right. So we are going to do the same stuff. We are going to do the same stuff. If root doesn't exist, return null. Return nothing. Otherwise, do the same stuff. In order, go to the root left. Then what? Print the root. Then go to the root right. Okay, class. So this is what? This is in order. And if I want to print the post order, do the same stuff. If root doesn't exist, return. Otherwise, go to the root left, go to the root right, and print the roots data. Guys, is it clear? Class, is it clear up to this point? Class, I'm assuming that you have done the same thing exactly like this. So if I call the function like it is pre-order, then call handle, then in order, and post order. If I do the same, if I try to execute, yes. 1, 2, 3, minus 1, minus 1, minus 1, and 4, we have minus 1, minus. You can say 1, 2, 3, 4, 3, 2, 1, 4, 3, 2, 4, 1. Class 1, 2, 3, 4, 3, 2, 1, 4, 3, 2, 4, 1. So if I do the dry run, if we do the dry run, if we do the dry run, so for this is our tree. One, two, three, four. So what should be the pre-order? The pre-order is in which, what is the pre-order? The pre-order in which we print the root first. So this is root 1, then 2, then 3, then 4. Because what should the in order look like? The in order is in which the root is in the middle. It is like root, left, right, then left, root, right. So the root would be in the middle. So first we are going to print the left sub part. So it would be like 3, 2, 1, 4. And in the post order, 3, 2, 4, 1. So we are getting the same answer. 1, 2, 3, 4, 3, 2, 1, 4, and 3, 2, 4, 1. 3, 2, 4, 1. So class, I am writing one dry run for you. I am doing that one dry run for you. Then you have to do the dry run for in order and the post order by yourself. So if it is like 1, 2, 3, and 4. Okay, class. Which dry run should I do? Which dry run should I do for you? Pre, post, or in? Guys, which dry run should I do for you? Because rest of the two you have to practice. Guys, which dry run should I have to do? Guys, should I do the dry run of this pre, or should I do the dry run of this post or this in? Guys, Sanjana, Darshan, Akhilesh, Mohammed Jasin, Shubham, Shruti, Dhanwant, Shri, Mohammed Ashif, Manish Basne. So, which dry run should I do? For the pre-order, post-order, in-order. Okay, class. I am doing the dry run for post-order. I am doing the dry run for the post-order. Okay. So the post-order code is look like something like this. If root doesn't exist, return, then go for the post, root left, then post, root right, and print the root data. If this is what my post order function. Guys, okay, you all are saying in order. Okay, I am okay. First do the post order, then we are going to do the in order also. First do the post order. Okay. So class, now we are at this position, which is what? Root. We are at this position, which is what? Our root. Class, now what we see? Root is null. Class, root is null. The answer is no. So we are, if answer is root is null, no. So we are coming to this line. We are coming to this line. Root is null. So this if condition would not be executed. Now we are going to this line. The roots left. Do nothing. Just simply move to the roots left. Okay. Do nothing. Move simply to the roots left. Again, this function would have got execute post. Again, we check root is null. No, root is not null. Again, we come to this post. Again, what? Move towards the root left. Okay. Again, we are moving towards the move roots left. Again, root is null. No, currently the root is at 3. The root is not null. The root's data is, the root is pointing to null. It is pointing to 3. Again, what we check? Root is null. No. Again, point what? Point again to the roots left. Go again to the roots left. Now again we move to the roots left. It is point. Now we check. If we see that this condition gets hit, we see that this condition gets hit. Root is pointing to null, means do nothing, simply return. It is saying do nothing, simply return. We are doing nothing. We are calling just simply return. Return directly, do nothing. So what we are doing? We are returning. We are returning. Okay, at this point. So now we are returning. We have executed this line. Now this line would get execute for this 3 as a node. Move to the roots right. Move to the roots right. Move to the roots right. We are moving towards the roots right. Okay. Again, this function would get execute. Again, I see that this if condition is being get hitted. Root is null, yes. Do nothing, simply return. Do nothing, simply return. Okay, we are doing nothing, we are simply returning. Okay, you can see this line is also executed, this line is also executed. Now we are returned for this line. Now this line would get execute like see out roots data, means print the roots data. What is current root 3? So prints a root data. The root data would be what? 3. The post order we are getting 3. Okay, now this function body is being executed. Now the function body is being executed. So when does the function execution stop? Either we hit the return statement or either the function body get executed. So here the function body get executed. So I can say that for this 3, the left is okay, the right is okay, and we have printed the data. Now what we are going to do, it is going to return. It is going to return. If for this left, we have done all the stuff. For this left, we have done all the stuff. So we are moving back. Now again I check 2. For the 2, the left has been done. You can see that for left has been again, this line has been executed for this 2. For this 2, this line has been executed. Now we are moving this line for this 2. So it is moving towards the right. It is moving towards the right. Okay. Again, what we encountered, this line would get hit. Oh, we got null. So do nothing, simply return. Do nothing, simply return. Okay. Now this line would get got executed because this line has been executed. What do? Prints the roots data. The roots data is 2. We are going to print it. Okay, 2. Now do what? Function body stops. Now it's going to return back. Okay. Now for this one, this left line has been executed completely. Now this right line would got execute. Okay. So it would move toward the right hand side. Again, this line got executed. Now for this 4, this function would execute again. So this left line would be encountered again because it is not null. So okay, again what we encountered? Oh, it is encountering null. So do nothing. Return back. Again what we encountered? It would the left is executed. Again the right would get execute. We are encountering what? Left is null. Then do nothing. Simply return. Again print the data. So what we are printing? We are printing the 4. Now for this one, this left is also executed, this right is also executed. Now this line would execute. It means print the roots data. Print the roots data. What is roots 1? 3, 2, 4, 1. So class, we are getting, sorry, we are getting 3, 2, 4, 1 with the help of this. Guys, is it clear? Class, is it clear how we are doing? How we have done the dry run for this post order? Guys, is it clear? Write true all of you in the chat box if this is clear to all of you. Okay, guys. So your homework is do the dry run for class. This is dry run for post order. So do the dry run for in order and as well as the pre order. Guys, is it clear? I am giving you 5 minutes. Do the dry run of in order and do the dry run of pre order. Class, is it clear? I am giving you 5 minutes. Do the dry run of in order and do the dry run of post order. And class, no cheating. Please don't cheat yourself. Don't cheat your dreams. Do the dry run for this and do the dry run for this. Okay? You should not cheat. Okay, class? Do not cheat your dreams. Do a dry run for in order and do a dry run for post order. I am giving you 5 minutes and we are going to begin at 10:50. Class, is it clear? Okay, do the dry run for these. Okay, class. I think you have done the traversal. Guys, have you done that? Write through all of you. Okay. Write your name. Write your name. Guys, those who have done the traversal, write your name. Guys, those who have done the traversal, write your name. Guys, those who have done the traversals, please write your name in the chat box. What about others? We have only two answers, two response. Dinesh Kumar, Shruti, Jay Narayana, Shandhya, Double E 034, Priyadarshini, Tejashri, Prince. There are a couple of more. Guys, why you are not doing the dry run? All of you. Parmisha, Harni, Manish. Okay, class. I think you have. I don't know whether you have. There is someone who wanna speak. Yes, Navin. Naveen, you wanna say something? Okay, class. So, class, open your laptop. See question number 94 on the lead code, 144 in the lead code, and 145 in the lead code. Guys, open your. Okay, this is your homework basically. These questions are the traversals on the lead code. The question number what? Guys, again I am writing. You have to do these. Question number 94, 144, and 145 on the lead code. Guys, you have to solve these three questions. Question number 94, question number 144, and question number 145 on the lead code. Class, is it clear? All of you? Class, is it clear? All of you? Guys, write one. All of you in the chat box if this is clear. All of you write one. Guys, all of you write one in the chat box. Class, be responsive. Guys, what about others? Their strength is 500 and I am getting only 10 responses. Guys, what about others? Guys, what about others? Class, please be responsive. Guys, be responsive. Class. Now we are going to solve couple of more questions, couple of more random question. Class, now we know that how can we create a tree? How can we create a binary tree basically, more precisely? Now I am asking you a certain basic level of questions, like basic level of questions. The question is, can I find the sum of all the nodes? Sum of all the nodes in my binary tree. Guys, write a piece of code, write a function that could return the sum of all the nodes in my given binary tree. Guys, can you solve it? Can you find the summation? Guys, write a piece of code that return the sum of all nodes in a binary tree. What I am saying is that if this is a binary tree like 1, 2, 3, 4, so you have to write a piece of code which return me its sum. Sum of my binary tree means 1 plus 2 plus 3 plus 4, which is basically 4, 3, 7 to 9 plus 10. This answer should be what? 10. Guys, is it clear? Write true all of you in the chat box. Guys, is it clear? Class, is it clear or not? Class, is it clear or not? Class, is it clear or not? Guys, is it clear or not? All of you. We are not moving ahead until you are responding something. If it is your break, guys, it is your break in the college or not? Guys, it is your break time in the college? Guys, it is your break time in the college. Anyone? Harshita, Harni, Sandhya? I am not able to understand what you mean by yes, sir. If it is a break time, then what is your break time? 11, 10, just let me know. No, it is not the break time, no, exactly. So, write a piece of code. This class would end in another 60 minutes. It's okay. We are going to do couple of simple questions and that they would be very easy. So we are going to solve a couple of very easy questions because this is the just intermediary class. I'm unable to send message, sir. Sajid, but you are able, all of you, some of you are able to send message and some of you are able to not. Now you are able to send. Sajid, you are able to send now. So 10, 20 to 10, 35 is break time, sir, and we have utilized your break. I'm sorry for this, but we have another 60 minutes, and after the 60 minutes, you have break for your whole day. Guys, is it clear? Now we are going to write a piece of code in which what we are going to do. We are going to find sum of all nodes. So I could say that I am giving a function which is int basically sum of node, and what we have? We have tree node star root, and we have to find the sum. So class, what is the first step? Check whether the root exists or not. If there is no root, means there is no sum, so return 0. If the root exists, if the root exists, what can we do, class? Think about yourself. What can we do? I am giving you 2 minutes to think. Just write a piece of code. This is the first line. I am writing it for you. It is the first line. I am writing it for you. Okay, class. I could say that now. Just listen. If this is my binary tree, 1, 2, 3, 4. So I could say that find the sum of left subtree, find the sum of right subtree, and add the sum of left subtree plus right subtree plus the roots. What I am saying is that find the sum of left subtree, then find the sum of right subtree and add the value left, right, and the current value. So we are doing the same stuff. Int left sum is again what? Call the same function sum of node roots left. Int right sum sum of node root right, and do what simply? Now add all of it and return it. Return left sum plus right sum plus this roots data. Finish. Only 4 lines of code. Guys, class, is it clear? How we are writing this function? Guys, is it clear? Class, is it clear? Guys, is it clear or not? Class, is it clear or not? Write true if this is clear to all of you and write false. Write true if this is clear and write false if you want me to explain it again. Guys, be responsive. Otherwise, we are not moving ahead. What about others? Harshita, Sandhya, Priyanka, Harni, Akhilesh, Prakash, Darshan, Premisha, Rachri, Ligith, Legit, Sindhuja, Jay Narayana, Dinesh Kumar, Manisha, Tejashri, Prince, Hari Prasad, Priyanka, Parmeshwaram, Kartiban, Nathira, Sweta, Jay Surya. Sir, explain again. Okay. The question was simple. If it is a binary, if we are given a binary tree 1, 2, 3, and 4, I want that return the sum of this binary tree. Return the sum of binary tree. So what I am saying, I could do it in a simple method. So what a simple method? Find the sum of left subpart, find the sum of right subpart, and we have root itself. So do the summation left, do the summation right, and add the roots value. We can do this. Very simple. Manivelan, I'm sorry if I'm not able to pronounce your name correctly. So I would say that Mr. K simply. Manivelavan. I'm not able to I'm sorry if I'm taking your name wrong, any one of you, because I'm not used to pronounce such type of names. So pardon me for my mistakes. Okay. So I am doing the same stuff. I am doing the exactly same stuff. So first of all, we should check now whether root exists or not. If there is an empty tree, the sum is what? Sum is zero. So we are doing the same stuff. First, we are checking the root. If root is null, do nothing, simply return zero. Then what I am doing, I am finding the left sum. Is sum of node root left. Then what I am doing, I am doing the same thing. Find the right sum of node root of right. Then again, what I am doing, just return left sum, right sum, and the roots value. Return the left sum, right sum, and the roots value. Is it clear now? Is it clear now? So if we try to write the piece of code for it, so how can we write the code? The code is very easy for this. Training SPCE. Guys, my VS code is visible. Class, do my VS code is visible to all of you? Guys, do my VS code is visible? Class, do my VS code is visible? Guys, okay. So light write a function. I'm just calling it as a sum of nodes. So what we are checking? First, we are checking whether root exists or not. If root is null, return zero. Otherwise, find the left sum. I am finding the left sum and just moving towards the roots left. Then finding the right sum and in the end returning their sum, cumulative sum. Left sum plus right sum plus roots data. And if I let's comment out this for time being, see out sum of node and pass this root. If I try to do 1, 2, 3, minus 1, minus 1, minus 1, 4, minus 1, you can see now the pre-order is 1, 2, 3, 4, and the summation is 10. So this is how we can find the summation of all the nodes in a binary tree. Class, is it clear? Class, write all of you one in the chat box if this is clear to all of you. Guys, write one and do the dry run for it. Write one and do the dry run for it. We're going to do the dry run for the same. I'm giving you 2 minutes. Do the dry run for it. Okay, class. So let's do the dry run for it. Okay. So how we are going to do the dry run? Let's do the dry run for it. So we have a tree as 1, 2, 3, 4, and this is our piece of code. So let's do dry run for it. So initially we have one. So one is not the null. So we are moving toward we are calling this function and we are finding the value. Now we are moving to the left of it. Again, we are moving to the left of it. We are moving 0, we are getting 0. Similarly, we are getting 0 from this side. And 0, 0, 3, what we are returning here? We are returning what? 3. We are getting 0 from here. 3 plus 2 plus 0, what we are sending here? 5. Similarly, what we are sending here? 4. So 4 plus 5 plus 1 plus 4. 5 plus 1 plus 4. What is the answer? 10. So we are getting the answer as 10. Class, is it clear na? Harshita, Sandhya, is it clear? Mani Velavan, is it clear that how all the things are happening in this? Class, now there is a very interesting question. The question number is 404. Let's discuss that. Class, this question number 404. The question is saying you are given the root of a binary tree, return the sum of all the left leaves. Means class, it's 3, 9, 20, 15, 7. Let's write it somewhere. 3, 9, 20, 15, 7. And what we have 7. So class, what are the left leaves in this? Class, what are the left leaves? I could say that this 15 is the left. Again, I could say that this 9 is also left. Class, I could say that this 9 is left and this 15 is also left. So what are these sum? The sum of this 15 and sum of this 9. 15 plus 9 is what? We have 24. So that's why what we are getting answer as 24. In the example number 2, we have only the single element like 1, it node itself. Do we have any left tree? Do we have any left tree? No. So what is the answer we are getting? We are getting 0. Do we are getting any left tree? No. So what's the answer we are getting? We are getting only 0. So class, if this was the sum for finding the sum of all leaf node, and with this line we are able to calculate the sum of left node, and with the help of this line we are calculating the sum of all the right node. So how can we make changes in this code in order to solve this? In order to solve this question number 404. So class, all of you open question number 404 on the lead code. Guys, open question number 404 on the lead code. Question number 404 in the lead code. Guys, all of you, open question number 404 on the lead code. Sum of left leaf nodes. Okay, open question number 404. So how can we solve it? So Class, how can we solve it? Anyone? I'm giving you 2 minutes to think. You have just 2 minutes to think. Just let me know. How can we solve it? Okay, class. You have to do it in your homework because we have couple of more things. So we are going to discuss it tomorrow. So class, what homework? What we have? We have 94, 144, 145, and 404. So class, these are the piece of questions that you have to do. Now, let's discuss the next question. Find the height of the binary tree. Find the height of a binary tree. Guys, how can you find the height of a binary tree? Anyone? Guys, how can we find the height of a binary tree? Class, first of all, what is the height? If this is our binary tree, one, two, three, four. So I could say what is the height? One, two, three. There are. This is the height. One, two. So what is the height of this binary tree? The height is class basically three. The height is three. So we have to find the height of a binary tree. How can we find the height of a binary tree? All of you class. Guys, so let's discuss what is the height. So again, we could do the same stuff. Just as we have found the sum, find the height of the left subtree, find the height of the right subtree, and in which is the maximum, add one to it because of the root height. So class, what I am doing, find the height of left subtree And similarly, find the height of right subtree and do what? And return the maximum of it. Because in this, the height of left subtree is 2. In this, the height of right is 1. And which is maximum? The maximum is 2 is and add 1 to it. 2 plus 1. So what is the height? The height is 3. So return the maximum of left subtree and the right subtree and add 1 to it in order to get the answer. So how can we write the code? The answer would be simple. Int height of a binary tree, we are getting root. So do the first simplest stuff. If there is no root, there is no height. Return 0 and find the height of left subtree. Roots left and find the height of right subtree. Root right. Find the maximum of it. Return after return what? Max of LST, comma RST plus 1. Simple. This is the how we can find the height of any binary tree. Class, is it clear how we are finding the height of a binary tree? Class, is it clear how we are finding the height of a binary subtree? Guys, write one true. All of you write true. All of you. Class, write true. All of you. So how can we write the code? Let's write the code. It would be very quick. We are going to write the piece of code for this. So whether our code is working fine or not. So let's write the piece of code. Int height. We are passing the root and we are checking if the root exists. If root doesn't exist, return 0. Find the height of left subtree. And it is like root of left. Then find the height of right subtree. And from the root of right and return max of LST, RST, and plus 1. And if we found the height, of root, let's try to do this. 1, 2, 3, minus 1, minus 1, minus 1, 4, minus 1. So we are getting 10 and 3. For this 10 and 3, we are getting 10 and 3. Class, this is clear? We are getting 10 and 3. Class, write all of you 8 in the chat box if this is clear to all of you. Write 8 in the chat box. Guys, all of you, write 8 in the chat box. Class, write 8 in the chat box, all of you. Guys, am I audible or not? Guys, am I audible or not? I guess I am audible. So class, this is how we are going to find the height of a binary tree. Okay. Now, this is height. So we could easily find class. For this binary tree, this is 1, 2, 3, and this is what 4. So, and other tree, it might look like this. So class, what is diameter here? Class, what is diameter here? This is diameter if I say like 1, 2, 3. This is diameter. And what is diameter here? This is diameter. 1, 2, 3. This is diameter. 1, 2, 3. So what we observe? Diameter, when we are finding the diameter of a binary tree, it is not necessary that it would always pass through the root. It is not necessary that it would always pass through the root. It would always pass through the root. You can see that in this case, it is not passing through the root. It is not passing through the root. So how can we calculate the diameter of a binary tree? Class, my question is clear now. How can we calculate the diameter of a binary tree? Calculate the diameter of binary tree. Class, one more question. Guys, do you guys need this code? Sorry. Let me explain this again. My screen was not visible. Class, these are the two subtrees 1, 2, 3, 4, and one of the trees 1, 2, 3, 4, 5. You can say in this case the diameter is this 1, 2, 3, but in this case the diameter is this 1, 2, 3. 1, 2, 3. In both the cases the diameter is 3, but what we observe that in this case when we are calculating the diameter, this root is included. Root is included. But when we are calculating diameter in this case, the root is not present. Root is not included. Root is not included. So class, what can we say that? It is not necessary that root is always included while calculating the diameter of a binary tree. But on the other hand, when we are calculating the height, the root is always included. But when we are calculating the height, the root is always included. But when we are calculating the diameter, the root may be included or may not be included. So how can we find the diameter of a binary tree? The real question is, how can we find the diameter of a binary tree? Class, is it clear? How can we find the diameter of a binary tree? And class, one more thing. Do you need this code? Do you need this code? Shall I share this code with you or not? Class, do you need this code or not? Guys, do you need this code or not, right? Yes or no, at least something. Okay, class. So let's see that how can we find the diameter of a binary tree. So if we observe carefully, what we observe, that we observe only these two conditions. Either root is included or root is not included. Root is not included. So I could say what simply, at each level find the height of left subtree, find the height of right subtree and add them. What is 2 and what we are getting 1? So the answer is 3. At this level 2, 1, the answer is 3. And at this level, what is the height of this tree? 1, 2, 3. Okay, what we are getting 3, what we are getting 0. So what is the diameter for this? We are getting 3. What is the diameter for this? What we are again we are getting 3. So class, we are going to use only these simple option with the help of this height. We are going to find the diameter of our binary tree with the help of with this with the help of this height function. We are going to find our diameter. Guys, can you do this or shall I do it for you? Guys, can you do this or shall I do this for you? Guys, can you do this or shall I do it for you? Guys, say something. I'm giving it 1 minute to think. How can you solve it? At 11:36, we are going to begin with the solution. Class, we also have this question on the lead code also, question number 543. Class, this question is also present on the lead code. The question number is 543. Find the diameter of a binary tree. Class, all of you open this question. Question number 543. And the question is pretty simple. We are given a tree and we have to find what? We have to find the diameter. And let's try to solve that only. This question. We have to find a diameter of a binary tree. So there are certain examples which are given to us 1, 2, 3, 4, 5. So let's see that 1, 2, 3, 4, 5. So in this example, this path and this is the diameter, or either this could be diameter. In both the cases, the diameter is coming to be 3. So we could either calculate this path or this path. And 4213 is also giving diameter of 3, and 5213 is also giving me the diameter of 3. So we have to find the diameter of different trees which are given to us. So the question is, how can we find the diameter? So class, open question number 543. Question number 543 on the lead code. Class, a simple thing. If a simple thing. If root doesn't exist, what is the answer? Return 0. We're going to discuss all the things, all the edge cases one by one. How can we find the diameter? The question is, how can we find the diameter? Guys, open your something, open, be responsive. I'm not going to discuss until you are responding to something. I'm not moving ahead until you are not going to respond something.
Uh, Hello.
Yes, sir.
Sorry, this is Giridharan from Meet College. So actually, there is a problem with Webinar Jam, so it was not able to send the chat. So students are trying to send the chat, but they were not able to send it.
Okay. So they are not able to send the messages.
Yes.
Okay. So that's why I was asking them chat. I think it should entire
It
screen.
was not sending the messages.
But I would convey the message to the team, but right now, why they are not? Because you can see I'm getting some chats, but in the setting, all messages are
No,
public. Now they're able to
no.
respond.
That is not the problem. Maybe due to this Webinar Jam platform, the session may be so it may be configured for 2 hour sessions.
Okay.
So
So
after
that's
two
why
hours,
they. Okay, sir.
yes,
Then
after
I
that
would.
they were not able to send the message.
Okay, sir. Then I would convey this message to the team so they could fix it.
Sure. No.
Okay.
So I'll take care of it. So tomorrow we can see this. So maybe you can
Okay.
assign some task and then you can close the sessions.
Sure, sir. So let I have certain lead code questions for them. So guys, as you know that
Sure,
I
sure,
have
sure.
mentioned certain lead code questions. The question number is these 94, 144, and 145. These questions are for your pre-order in order traversals. Then this 404 is for sum of leaf node. Then we have this 543 for finding the diameter. Just read the question. And class, there is one more question which is finding the height of a binary tree. Height of a binary tree and maximum height of a binary tree. Okay, yes, this question is a little bit different. Not exactly, but this question is a little bit different. Just and read what is depth and what is the height. So this question number 104. This question number 104. So class, your homework is you have to solve these questions. I'm writing here with a black pen: 94, 144, 145, 404, 543, and 104. This is for height. This is for diameter. These three are for traversals, and this is like summation, like that we have done. Find the sum of all the nodes, but this question is a little bit different. It is sum of left leaf nodes, sum of left leaf nodes or whatever. Let's check. Yes, sum of only the left leaves. Left leaves, the leaves which are the left. You can say 7 is also leaf, but 7 is the right leaf. So we have to find the summation of only of the left leaf. Okay. So you just read the question. We are going to solve them tomorrow if there is any issue while solving them. So before discussing the session, before starting the session, we are going to complete this question 543 and diameter. We are going to discuss the diameter in detail. And after this class, you have to read about something which is called BST. Some students have mentioned that, like Madhushri, I don't know, Priya Darshini, what is BST? So read about BST. The full form is binary search tree. Okay, class. So you have to solve these questions 94, 144, 145, 404, 5, and read about BST. And class, I am also sharing this code with you in the chat box. So you could have a reference. My voice is breaking. I'm sorry for it. Now it's clear, Sandhya? It's clear. It's still there is some lag. I don't know. So I am sharing the code with you. Again, I am also not able to send something. Hello. Okay, I don't know. There is some issue with the platform. The network is good at my end. Okay. The event maximum duration is you have been on air for. Sir, send me the list of question. The list of question is, I am just writing the question number. Please note it down somewhere. These are the question number, class. These are the question numbers, class. 94, 144. Note it down. These are the question numbers. Guys, note it down somewhere. Mahashri, please note it down these numbers. Take a snapshot or whatever you want to take, note it down these numbers. These are the lead code question numbers. Okay, class. So I think we should end the session here, and class, Thank you so much for listening me patience. The lot of patience. And guys, please read and discuss all the topics that we have taught today. And please read about the binary search tree and try to solve all the questions that have been mentioned. Okay, guys. Bye bye. Thank you and do practice. Sure. I would try to send the code to the staff. I would create the .txt file and I would let you know. I would I would send the code to the staff. Okay? Yes, Sandhya, I would definitely share the code. I would definitely share the code. Please, someone share your email ID or I would share the code. I would definitely share the code. Okay? Thank you, class. Thank you, class, so much. Have your lunch and keep practice. Keep doing practice, class. Bye bye. Yes, sure. I would share the mail at this mail ID. I would share the code. I would share to one of you, please. I would share the code to one of you. I am sharing the code to one of you right now. And now please share that file in your. Okay, class. I have shared the code with Viduran and let me share it with Sandhya also. So Sandhya Viduran and please share the code to the complete class. Okay. Okay, Harshita, I am sharing to the couple of guys. So kindly share the code to all of you. So I have shared the code, guys, to couple of students. So class, bye bye. Thank you so much, class. Keep practicing and see you tomorrow, guys. Bye bye. Okay. I am also sharing to the Arun Kumar also, and I would share. I am sharing. Okay. Then received. I think all of you have received the code. Deepa Shahana, I have shared. Okay, class. I have shared the code, I guess. All of you. Thank you, class. Thank you very much. Okay, class. Bye bye.